Alright, so this is Honors Geo, Chapter 4.1 and 4.2. Applying triangle sum theories and congruent triangles. Okay. Well, we all should know what a triangle is, but to refresh your memory, a triangle is a polygon with three sides, essentially. When we describe it geometrically, if we see a triangle like this, A, B, and C, when we write this out, we just say triangle A, B, C. The triangle symbol and then the letters. It could be BAC, CBA, and any iteration of those three letters. There is no specific order to them unless we talk about congruent triangles or similar triangles where you actually do have to have them correlate to their corresponding sides, and we'll talk about that later. Specific type of triangles that are given here, this is all review. We have a scalene triangle. When we talk about a scalene triangle, we're talking about triangles with no congruent sides, or angles. No congruent side or angles. We have an isosceles triangle, and an isosceles triangle I guess I'll take out the angles part since we're talking about sides right here. Isosceles triangle, you have at least two congruent sides. And then we have an equilateral where all three sides are congruent. And I'm going to draw it all out. We also have an acute triangle. This is by angle. This is the first part was classifying triangles by their sides. Here's classifying triangles by their angles. And we have an acute triangle where all three angles inside the triangle are under 90 degrees. Acute. And a right triangle where at least one triangle is 90 degrees. One of the angles inside the triangle is 90 degrees. We have an obtuse triangle where one angle inside the triangle is over 90 degrees. And then we have an equiangular triangle where all three angles are the same. Another type of triangle that they don't say here is a regular triangle. I don't know if they talk about later in the section. But a regular triangle is a triangle that's both equilateral, meaning all angles are the same, and both equiangular. All angles are the same. They're called a right triangle. You can classify what type of triangle is by their distances on a coordinate plane, and you do that by using the distance formula. So you would get ordered pairs, and then you would get the distance between those ordered pairs, and based off of that you can determine what type of triangle it is. Just to refresh your memory, the distance formula is x squared minus, or x1 minus x2 squared plus y1 or y2 minus y1 squared, and the whole thing is being square root. And remember, the distance formula is just a version of the Pythagorean theorem. So there's two ways, or there's two processes that they do here. In order to determine what type of triangle it is, you got to determine either by its side or by its angle. So the only thing you can really determine is whether the triangle is a right triangle. You can tell the distances to tell if it's either scalene, isosceles, equilateral. And then to determine the angle, you can determine if an angle is a right triangle by multiplying their slopes. And if you multiply the slopes of these sides and you get one that's a negative reciprocal, or sum up to -1, then you can get a perpendicular or a right angle. That's about the only way you can classify whether it's right or not. You can't really tell if it's obtuse, acute, or equiangular, but you could tell if it's a right triangle. So get the distances of all three sides and then multiply their slopes. And remember, to use the slope is the slope for you is y2 minus y1 over x2 minus x1. Interior and exterior angles. So if we was to expand the triangle out like so, these guys on the inside of the triangle, these guys would be called exterior angles. So I'll say 1, 2, 3. So angles 1, 2, and 3, they are interior angles. Angles formed within inside the polygon itself, the triangle itself. Then if we were to extend these triangles out in terms of lines, angle 1 can form an angle over here. They can form a linear pair going this way, and on the other side it can also form a linear pair with angle 1. Angle 2 can form a linear pair over here. It can also form a linear pair over here. Angle 3 can form a linear pair over here. It can also form a linear pair over here. So there's two linear pairs per side, per angle, interior angle. And these angles, we can say 1, 2, 3, 4, 5, 6, 7, 8, and 9. These guys are called exterior angles. And they form linear pairs with the interior angle, so there's always two. And we can use the fact that exterior angles form linear pairs and a straight line is 180. We can use that to determine that the interior angles of a triangle all sum up to 180 degrees, which gives us triangle sum theory. Triangle sum theorem. And the triangle sum theorem says that the sum of the measure of the interior angles is 180 degrees. And I'm going to write it down because it's right there. And we can prove it. And we can prove it by drawing something called an auxiliary line. And this is used a lot in proofs to prove angles or types of angles. It's used a lot to prove interior angles of polygons. And an auxiliary line can be used in a proof of the triangle sum theory. And what an auxiliary line is, that in any proof you can draw any line through a point. Any line can be drawn through a point. So you can add it to anything in a particular line for proofs. So that is what auxiliary line is. Just a line that you add into a proof to prove your proof. So here's the proof of the triangle sum theory. And the proof is this. We have a triangle ABC, and we're going to prove that the interior angles 1, 2, 3, and 4 are 1, 2, and 3 rather are equal to 180. So what's going to happen is we're going to draw an auxiliary line that's parallel to one of the sides of the triangle. In this case, it's going to be parallel to AC. Alright, so now we have a pair of parallel lines. This is going to be my transversal, AB, and BC is going to be my transversal, and we're going to use that to prove that these guys are 180. With the auxiliary line, we have these three angles. We can use angle addition postulate to say that 4 plus 2 plus 5 is equal to a straight line, which is what this guy is. And we're going to say 4 plus 2 plus 5 is equal to a straight line, therefore it's equal to 180 degrees. Once we do that, then we can use alternate interior angles to say 4 is equal to 1, alternate interior angles to say 5 is equal to 3. We have 2 equal to itself, so then 1 plus 2 plus 3 equals 180. That is the purpose. So if we look at the proof, it says draw a line parallel to BD, draw BD parallel to AC. So we drew our auxiliary line. It's called the parallel postulate. That we can draw a line. If you remember parallel postulate, we have a line, we have a point. Through that line says that at one given point we can draw a line where there's a one and exactly one line parallel to the point. We did that earlier in chapter 2, I believe. Parallel postulate and perpendicular postulate. So that's what we did. We drew a line, and we drew a line that was parallel through that particular point at point B. Then this sort of merges two a postulate and a definition of a straight angle, and they merged it together. And they saved a lot of steps. Like you say, the line BD is equal to a straight line, definition of a straight angle. And then you could say 4 plus 2 plus 5 equals a straight line. And then use transitive and say that it equals to 180. They merged it into one, so I'd also recommend it. It saves time. You don't need to actually expand this part out. Angle 4 plus 2 plus 5 equals 180 degrees. And you can actually write two reasons for that and merge them. That's okay. In this particular case, when you're drawing some auxiliary line. When you draw an auxiliary line or something like that, they can merge various reasonings in a proof. So it's a angle addition postulate, because 4 plus 2 plus 5 equals the straight line. Straight line equals 180 degrees, and then you merge them together. And we get that equals to 180. Since we have two parallel lines crossed by these transversals, I can say that 4 is congruent to 1. I can say that 5 is congruent to 2. And then I can say they're equal to each other. And then lastly, I can substitute and say, okay, well, if 1 is equal to 4, I can substitute 1 here. If 3 is equal to 5, I can substitute 3 here. And I can say 1, 2, and 3 equals to 180. Substitution property of equality. And then we have also the exterior angles theorem. And the exterior angles theorem says that angle 1 is equal to the sum of the measures of the non-adjacent interior angles. So what does that mean? Let's go angle 2, angle 3. Let's call you angle phi. We have an exterior angle out this way, and let's call that angle 1. So this is what the exterior angle theorem says. It says that angle 1 the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. That is the exterior angle theorem. This angle on the outside is equal to these two guys. Non-adjacent interior angles. This would be an adjacent interior angle, angle 4, because they share a common ray that makes them adjacent to each other. And if we was to add these two guys together, we know that they are equal to each other. And then there's some algebra that says that you can do math and stuff and solve for x. I'm not going to go through that. Corollary to a triangle is something theorem. And the corollary says this. Acute angles of a right triangle are complementary. Acute angles of a right triangle are complementary. What does that mean? First of all, what's a corollary? Corollary. Yeah. Corollary is a to a theorem. Is a statement that can be proved easily from the theorem. So we proved triangle sum theorem and set them all equal to 180. We could have added something in there like, oh, let's say that one of the angles is equal to 90 degrees, and we can prove that the other two guys are complementary to them. Knowing that, for example, so this is the corollary to triangle sum theory. And the reason we can easily prove this is that if we know that one of the triangles is 90 degrees, so 90, 1, and 2. So if we were to say 1 plus 2 plus 90 equals 180, this is already triangle sum theory, right? 2, 3 angles interior eat up to 180. We subtract 180 from both 90 from both sides and say 1 plus 2 equals 90. Well, these two guys are complementing angles. just based off of that. So that's the thought process behind the corollary. We already knew that this was equal to 180. So we can easily add an extra condition. Okay, well, if it's 90 degrees, then we consider complementary by subtracting both sides from 180. That is the corollary to triangle sum theory. That if we have a right angle, then the two other angles are complementary and that there must be acute. Okay. And that's 4-1. Let's talk about fold 2. Applying congruence of triangles. So we have congruent figures. And congruent figures are where all parts are congruent between the two or more. So 2 or more figures, in this case like triangles, polygons, etc. In this case really polygons. 2 or more figures that in which all parts are congruent. Two figures in which all parts are congruent. That is a congruent figures. And if we have congruent figures, they have corresponding parts. And it's going to be those corresponding parts that are congruent. In this case, we're going to have corresponding sides. And we're going to have corresponding angles. And they're going to be congruent if I'm dealing with congruent figures. Corresponding parts are congruent. The parts that make up those corresponding parts are corresponding sides and corresponding angles. Okay, so here we have triangle ABC. Actually, let's do it like this. A, B, C, and then we have triangle FED, EFD, EFD. Why would it do it like that? FED. None of my triangles aren't accurate, so don't judge me. F ED. Okay. We have one marking here, one marking here, two markings here, two markings here, three markings here, three markings here. We have one angle marking here, one angle marking here, two angle markings here, two angle markings here, three angle markings here, three angle markings here. Okay. We can write that the triangles are congruent in different ways. We can write triangle A, B, and C. Notice I'm doing it based off of their corresponding angles. Is congruent to triangle F, E, D. Okay, here's the corresponding, right? A has one marking, F has one marking in terms of the angle, so F correlates to A. B is over here, has two markings. B, E is over here, has two angle markings, so B correlates to E. And then C has three markings and D has three markings. So C correlates to D. That's how I write them. And I could write them in any iteration thereof. So I could have wrote them as B CA is equal to EDF. I could write that CBA is equal to DEF. As long as they're as you write them according to their corresponding angles, when you write the triangles, then you're fine. The angles that are congruent to each other, right? Angle A is congruent to angle F. These terms are corresponding angles. Angle B, what the heck? Angle B corresponds to angle E, and angle C is congruent to its corresponding D. In terms of sides, side A, B is congruent to side FE. Side BC is congruent to side ED, and side AC is congruent to side FD. Yep, those are the corresponding sides, those are the corresponding angles of this triangle. If all corresponding sides and all corresponding angles are congruent, then I can say that those triangles are congruent. Alright, here's some algebra involved with it. Knowing that they're congruent, then I can set corresponding sides equal to each other and solve for various variables. So I'm not going to do that. Here it says that quadrilateral ABGH is congruent to CDEF. Again, when they label this, that means that A corresponds to C, B corresponds to D, G corresponds to E, and H corresponds to F in terms of their angles. So you knowing that, you have enough information to find out where all the corresponding sides are. So it says, identify all pairs of congruent parts. You don't really even need to figure. As long as you have this guy, A, B, G, H is congruent to C, D, E, F. Well, again, like I said, I already know A corresponds to C, B corresponds to E, G corresponds to E, H corresponds to F. So in terms of the angles, I can easily just say angle A is congruent to angle C, angle B is congruent to angle D, angle G is congruent to angle E, and angle H is congruent to angle F. Those are the corresponding angles. In terms of the corresponding sides, AB, CD, BG, DE, GH, EF, and then these two, AH, CF. Just based off of the lettering of the polygon label. So I can say that AB, side AB, is congruent to side CD. And if you look at the picture, that's the case, AB, CD. But I'm looking at the actual labeling of the polygon. Since they tell me that they're congruent, they're already aligned correspondingly. BG corresponds to DE. GH corresponds to EF. And then AF corresponds, AH corresponds to CF. Alright. Down here, they want you to show, I'm not going to solve for all the x's, you can do that on your own. Here, they want you to show that the two guys are congruent. So we have all sides, corresponding sides congruent. Now we have to put all corresponding angles. We're told that PS is parallel. This is actually a really good one. Alright. Here's how to do this one. Okay. Okay. P, S, and T, Q, and R. We know that these guys are parallel. Parallel means something. It's an important clue. These guys are corresponding. These guys are corresponding. These guys are corresponding. Alright, so we have all the corresponding sides that we can say are congruent to each other, but we need angles. So we know here that these guys are corresponding because they're vertical. This is a parallel line, right? So if I was to expand it out, this guy, QS, would be my transversal for these two parallel lines, right? So we have alternate interior angles. So I can say that this guy here and this guy here are congruent because they're alternate interior angles. And I can say the same thing for these guys here as well. Expand this out. This is R. Expand this out. This is P. I can say, since this is interior, right, this is bottom right, this would be top left. They're alternating interior angles. And we know that alternating interior angles are congruent. Therefore, I can say that the sets of sides are congruent. Now I apply that all three angles correspondingly are congruent. I have enough information to say that they are. I can say, in terms of the sides, I can say that ST is congruent to QT. I can say that PT is congruent to RT. And I can say that PS is congruent to QR. Okay, those are my sides and then my angles. I can say that angle P is congruent to angle R. Angle S is congruent to angle Q. And angle PTS is congruent to angle PTS is congruent to angle QT RTQ. Alright, since I established that those two guys, that corresponding angles and sides are congruent, then I can say that triangle, do it in blue. Triangle, and I'm gonna line them by the angles again. Triangle PTS is congruent to triangle RTQ. Okay. Sorry guys, parallel lines doesn't go anywhere. And alternating angles doesn't go anywhere. And vertical angles doesn't go anywhere. Alright, third angles theorem. And what the third angles theorem says is that if two triangles are congruent, if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. Triangles don't have to be congruent. The triangles do not have to be congruent. Third angles theorem says that if two angles of one triangle are congruent to two angles of another, then the third angles are congruent. So in this case of the triangles, we have A and B, and the C and E. There are two triangles. Their sets of angles are congruent. If I know that those two guys are congruent, then I can say that C and D are also congruent. Okay, using proofs to prove that triangles are congruent. In this case, we just have to prove that all the corresponding sides are congruent. That's the definition of congruent figures. So here they give us a whole bunch of stuff. So really all we have to prove is that the third side is congruent to each other and that the third angle is congruent. So they already give us those. So given all these sides and angles are congruent, so the only thing we need to prove congruent is angle D and angle B. And if we look at AC, these two triangles share AC. So when we do something like this, I'm just going to do this as an, it's not the same triangle per se. Alright. So if we have a situation like this, and they share the same side, we can say that this guy is congruent to itself using the reflexive property. Reflexive doesn't go anywhere either. So we can use the reflexive property and say that it's congruent to itself, so we have three corresponding sides. So we have this angle and this angle. That means that these guys are parallel. And then we have this angle and this angle. So we can say that the third angles are congruent because of third angle theorem. And that's what they want us to say. Alright, so given reflexive property, AC is congruent to itself, so then I can say that, and then given the fact that the angles are congruent, I can say that B and D are congruent because of third angles theorem. So now I have all three sets of sides, corresponding sides congruent. I have all three sets of corresponding angles congruent. Therefore, I can say that triangles are congruent because of the definition of congruent figures. Alright, properties of congruent triangles. If we have two triangles that are congruent, uh, we can say that a triangle is equal to itself. So reflexive property of congruent triangles. Any triangle is congruent to itself. Symmetric property of congruent triangles. If triangle ABC is congruent to DF, then DEF is congruent to ABC. Just like symmetric properties of angles and segments. And we also have transitive property of congruent triangles. If one triangle is equal to a second triangle and the second triangle is equal to the third, or congruent, then the third triangle is congruent to the first triangle. These all apply. Alright. So that is this section. Hope you have a great rest of your day.